Let's finally talk about how we deal with situations where we cannot simplify the inside when we have variables. So if you had something like the square root of x to the third, I might write it out as x times x times x. A pair of x's comes out as a single x, and this lone x here, stays inside. If we had something like the square root of x to the seventh, what I know is that I would have 3 full pairs of x's inside. Because if I sort of round down, I know that the number that's right beneath x to the 7th, the term is x to the 6th. So that gives me 3 pairs of x's. That'll come out as x to the 3rd, and I know I will have a single x left over. If I had a few terms, if I had something like, let's say, the square root of x to the 5th and y to the 8th, what I know is when I go to separate my x's, I know I'll have 2 pairs of x's that come out because 2 goes into 5 twice. 2 goes into 5 twice. So notice what I'm doing is 5 divided by 2, right? 5 divided by 2 is really 2, remainder 1. So I know I'm going to have an x squared outside, and I will have an x left inside because of that remainder. However, the exponent on y is even, and 2 goes into 8 4 times. So my final answer for that radical is x squared y to the 4th square root of x. And finally, if we have a number involved, if we have something like the square root of 18 x to the 3rd, I'm going to handle them separately. Square root of 18 and square root of x to the 3rd. And what I know is the square root of 18 I can simplify into square root of 9 times square root of 2. So that will become 3. The 2 will stay inside. As far as my x to the 3rd, I'm going to have a pair of x's, so that'll come out as an x, but I'll have a single x left inside. So that just becomes 3x square root of 2x.